Alrighty, we'll keep going here. Welcome back. Another question. Let me check the audio, make sure that's working.
Hello.
Looks good. All right. Next question is flower planting with no adjacent. Okay, get that going. See how this goes. This one is a little bit lower success rate. Okay. Flower planting with no adjacent. You have n gardens labeled from 1 to n and an array paths where paths of I is equal to x of y. Y sub I describes a bidirectional path between garden x sub I to garden y sub I. In each garden, you want to plant one of 4 types of flowers. All gardens have at most 3 paths coming into it or leaving it. Your task is to choose a flower type for each garden such that for any 2 gardens connected by a path, they have different types of flowers. Return any such choice as an array answer, where answer by is the type of flower planted in the I plus 1th garden. The flower types are denoted 1, 2, 3, or 4. It is guaranteed an answer exists. Kind of a lot of downvotes for this. Not too many, but considerable number. So this looks like a coloring question, graph coloring question, and this is going to be 1 to 10,000 vertices. And it's a sparse graph, meaning it's only three paths coming into or leaving it. Every garden is at most degree 3, which means there aren't that many edges. I think it just means if every vertex is degree 3, I think that means it doesn't mean that there's 3 times n edges, because every vertex pair of vertices shares at least one edge. Like every edge is incident on 2 vertices. So that would mean the number of edges from the perspective of the vertices would be, well, the degree times 2, or excuse me, the degree times 3, the degree times the number of vertices, right? 3 times n. I think you've got to divide that by 2, because each edge would be incident on 2 vertices. So then if you take the number of edges and multiply it by 2, that's the sum of the degrees in the graph, and the sum of the degrees in the graph is bounded by 3n. So that means the number of edges is bounded by 3n over 2. A little bit confusing, I realize. Yeah, 2 times e is the sum of the degrees. And if the sum of the degrees is bounded by 3n, that means that 2e is bounded by 3n, which means that e is bounded by 3n over 2. Okay, got it. Got it. The worst case, you have 3n over 2 edges, which is sparse, right? Not that many edges. Okay. So we've got 20,000 paths. Oh, it tells you how many edges. Yeah, 20,000 paths. 10,000 vertices, 20,000 paths. This is actually somewhat incorrect. As mentioned, this should be, I think, 15,000. If the number of edges is bounded by if the number of edges is bounded by this really should be 15,000. If it's the number of edges is bounded by oh no, I'm sorry, is this 20? Yeah. The number of edges is bounded by 3 halves n. So 3 halves of 10,000 is 15,000. Yeah. Anyway. X sub I, Y sub I. So that's the graph. That's fine. It's graph in question. Any two connected have different types of types. So it's a 4 coloring. 4 coloring of a sparse graph. Well, that's interesting. I don't know. Since the degree is bounded by 3, I think you could do this in linear time, I want to say, or like you could do this rather efficiently. Hello from Nigeria. Hello. Hello. Nigeria, wow. They have, I should say that. Are you an African from Nigeria, or are you like a European guy in Nigeria? I hear that every now and then they have like Westerners that go over to Nigeria and do stuff, do work for them. Governments. So I'm wondering if I should take a node and color it with a 1, and then if it has 3 neighbors, color them each with different colors. That's like my first thought. And then for each node, just make sure every node that it's adjacent to, if it's not already colored, color it with I guess at each vertex, take a look at the neighbors and the colors of those neighbors, and then color them with like fill them with colors that haven't been used. Phrase it that way. And it could be random, I think. I gotta think about this. Like I think some kind of brute force approach should be fine here. Is sort of my thinking. Yeah, just lay down for a minute while I ponder this. I think it's excuse me. The only problem I can imagine is well, I could do a depth first search, I could do a breadth first search, I could do a level order traversal. There's a few different options here. There are a few different options here. I think breadth first search is probably the way to go. Excuse me, I guess the question I have is like, what if I look at a node that hasn't been colored yet? I look at its neighbors. Well, the neighbors could have the same colors. Yeah, it doesn't actually matter. Even if I have a particular node, it's got a bunch of neighbors, and some of those neighbors have the same color. Since the degree is only 3, it's always guaranteed that I could always assign a new color to every node, no matter what colors the neighbors have, and they won't conflict. Yeah, it's pretty easy actually. It's pretty straightforward. Yeah, okay, let's do it that way. That's actually really, really straightforward. Just breadth first search. It's fine. Breadth first search should be fine. I think this is probably a lot harder if And yeah, it's always possible to perform this coloring. So yeah, okay. This is not that difficult. Not that difficult. Okay, so an example will be 1, 2, 3. Oh yeah, and then I just have to. There's a few things here I have to do, but yeah, this is not too bad. So, all right, let's do an adjacency matrix. First things first. Let's do int array size n. Fill that with zeros initially. And then say paths, have an adjacency matrix. Which really should be a vector of ints. Right. And then we're going to say for each path, E in paths, A is E of 0 minus 1. So I'm going to make this all one indexed. And then we're going to say adjacency of A, dot pushback B. And same thing the other direction. Going to have a Boolean array of visited, VD, VD plus N is false. Going to have a standard queue of integers, Q, push VD 0 is true. Start off at 0. So while simple breadth first search works, Q is not empty. We're going to say constant index is Q dot front, Q dot pop. If visited of index, continue. Visit that index, say it's true. Visit that index is true. Gonna go through the neighbors and index, I guess. Adjacency of index. And say neighbor index. Or just other neighbor or an index or something. Say X, let's say Nix is fine. And I can say if not visited of Nix, then q.push Nix. And also, so actually, what I would want to do is, wait, I'll come back to that in a moment. And VD of Nix equals true. Okay. Now the color is going to be basically any color that hasn't been selected. So we're going to say bool array colors. And we're going to say for each neighbor, colors of, it's going to be colors of array Nix equals true. This array result is actually what we're going to return at the end. Okay. Hmm. I actually don't really need visited anymore. Could say array. Really don't need visited. You could just say array of. Give that first color 1. If it's 1 or more. Oh, actually, I think I'm doing this wrong. Let's go back. It's easier it's easier to think about if I do it the way I was already doing it. Okay, so here we would say if array of nicks current number color. You know, it might be easier just to add another element here. It's probably easier just to do that. No, I don't know. It's confusing. It's fine. There's probably a better way to do this that avoids a branch, but I'm getting too confused trying to figure that out. So we'll just say, so if array of index is 0, if not, this color hasn't been set yet, then we're going to loop through these current colors. So if not colors of I, then right, keep incrementing it until colors is 0. And then set array of ix equal to color equal to I plus 1. That's confusing. Yeah, basically loop through the colors that I found in the neighbors. So write the neighboring colors that I see, and then whichever of these neighboring colors that I don't see, that's what I'm going to write here into my onto my node, paint my node with that value. Yeah, and add 1 as well. And that's what I return at the end. I think that's it. It's a pretty straightforward thing. Am I doing on time? I don't have the timestamps, do I? And this is 20 minutes. I don't need that anymore. Wrong answer. Whoa. 0. Okay. Should start off with 1. What's going on here? May have gotten something confused. May have done something strange. It's index 0, so I don't get the neighbors. Huh? Okay. I think Nix might be a little too similar to an IX, quite frankly. Oh, there are no neighbors. Oh. Whoops. Okay. That's confusing. Still wrong. Okay, better. I can't do it this way if I, yeah, okay. Sometimes I get kind of confused with, like, because if I check things here and I set things there, that gets confusing. It definitely gets confusing. All right, got it in this case. How about this one? So we have 0 to 1, 2 to 3. Oh, okay. Got it. Got it. All right. Got to put all this code in a loop because the components are not necessarily all connected. That's interesting. Kind of did that quickly. There's probably an error mistake there somewhere. Okay. I don't know, push a high. There we go. Alrighty. I think it's right now. Let me fuzz it a little bit. So, took me a while to program this. I think I should have been able to program this a lot faster, a lot sooner. I think there's some test cases here. See if I can write a script. So I want an awk script, and I want to echo this awk script, add these things to the end. And inside my awk script, I want a bunch of different, basically random edges. Yeah, so I've got a few things that I want here. I want a seed my srand. I think I talked about that before with the date. Start with that. The date in nanoseconds. Let's do this way. Pretty sure. Okay, that works. Alrighty, srand, and now I want random number of paths. So I is 0 and I is less than, say, rand of integers. And I don't know, let's say at least 2 paths. And oh, actually this doesn't really work. Yeah, I'd have to probably use a Python script to generate the test cases because I don't have, I'd have to make the test case a little more sophisticated. I can't just randomly generate these things. That's my mistake. Yeah, the problem with this is that I think I'm just gonna go for this. Go for it. I think I'm just gonna do it. It could be something wrong. It's a good chance it's a mistake. Oh, got it. Okay, don't have to worry about all that. Got it. The problem is how do we do? Also, it's pretty quick. Okay, 80% is pretty good. Submit it 4 more times while I'm talking. All right. Well, don't have to think about it too much more now then. Okay. 2 more. Yeah, so the deal is with this that it's reasonable. It's almost 90% runtime. It's like a little over 80%, so that's pretty good. Generally pretty good. Yeah, so generating the test cases for this is definitely a lot more involved. What it would require is I have to guarantee all those different conditions that the degree isn't more than 3, and I'd have to generate random edges, and I'd have to generate the edges themselves. I have to generate the value n with respect to those edges. So it's a little bit it's a little awkward. Let's just say it's a little awkward. and I probably would want to use a Python script rather than a shell script. I guess you could use a shell script, but I don't think a shell one-liner is probably appropriate for that. It's like a little bit more involved to generate those test cases. But anyway, so okay, very good. I will stop here. I wonder if I want to take a break and just kind of think for a while. Take a break and think for a while. I could restart the stream on another question and keep going. I think I'm gonna take a break though. I might. I'm kind of deciding. I might take a break for a few minutes and then do another question. Just restart the stream on another problem. So yeah, thanks for watching. Like the stream. Don't forget to like the video and subscribe to the channel. And yeah, okay, that was that one. Not too bad.